Yeah, hi everyone. This is so cool. Actually, yeah, I'm really happy, James. Thanks for doing the this introduction. A lot of things happening today. I'm doing for the first time. Even though this talk, so I did 3 times already. So one in Warsaw, one in New York City, one in San Francisco, and every time something goes wrong, and because it's about AI. Every time, even you have your slides, all your demo crashes. Like I needed to fix everything in the morning because the demo did, like, they worked last week, so everything stopped working, so you need to update versions, format changes, so it's so cool. But if something failing, don't blame me, blame the, I don't know, somebody. Yeah. I wanted to say a couple of words about myself first, and yeah, I still using Twitter. So if you're there, why don't we be friends? So that's my hashtag. You can find it everywhere, almost like GitHub, Twitter, other social networks. And what James said about like how we met for the first time in Scottish Ruby user group, that's like very true. And another thing that James said, he was driving the panel discussion for 2 of the conferences that we were organizing. So one of the conference called Yuruko. I don't know, where is James? So spot him somewhere. So yeah, James was driving this panel last year in Vilnius. We hosted that. Who of you heard about Yuruko, by the way? Raise your hand. Okay, keep your hand up if you attended Yuruko. Okay, it's a good same hands, but cool. Thank you very much, guys. So yeah, for those who don't know, Yuruko traveling across Europe. So it stands for European Ruby Conference. It's like Eurovision, and yeah, and anybody can host it. So the reason why I took Yuruko to Vilnius was that me and James were sitting in the bar, and I was trying to convince him to pitch for Edinburgh, to bring Yuruko here, because like my gut feeling was that's the place that Yuruko needs to happen one day. So he was against. We got a little bit drunk, and I said, okay, if you're not gonna pitch for Edinburgh, I will pitch for any other city. And of course I pitched for Vilnius. And it happened, so I got the permission to host Yuruko in Vilnius for the whole year. And after Yuruko, we kind of started doing, because like Yuruko gives like a lot of inertia to community, we started thinking, okay, why don't we kick our own conference? And it looks like that's exactly the same thought that James had. And I don't know if you can figure out what's happening on this image, but so this one is clear. I really thought that you guys gonna have speaker faces inside of the Huggies. I wanted to do myself, but I thought like, okay, maybe that's too much, because like a lot of things happening for the first time. So yeah, like after Yuruko, we started a conference called Baltic Ruby. So it's exactly the same concept, but to the region of the Baltic Sea. So it travels across Norway, Sweden, Finland, Estonia, Latvia, Lithuania, Poland, and a little bit of Germany. And we had it last year in Malmö, in Sweden. And James was the person who did great panel with Mats about the future of Ruby. This year it's happening in Riga, and I don't know if I can invite people to come. So come to us this summer to Latvia. Riga, we're gonna have Tim Riley, the core team contributor of Hanami and DryRB. We're going to have 3 different directions to go. So it's open source track, it's a Ruby track, and everything else, like the Rails alternatives. Like we're gonna talk about Hanami, we're gonna talk about all other frameworks that survive, because we think it's valuable for community, not only focus on one solution. That's kind of a thing about myself. Apart from that, I work for for Cybergizer, we've been doing Ruby and Ruby consultancy for a decade already. We are located in Lithuania and Poland. And as I mentioned, today I'm doing a lot of things for the first time. So I'm wearing kilt for the first time. I don't know if it's, I've asked James if it's appropriate or not. There are so many other things that you need to know about, like wearing kilt. I'm still learning a little bit. So, so for the first time, my daughter listening myself, so she's here. And it happened that my family came to pick up my daughter because they live in Inverness, and so they are also here. So I cannot use rude words. I cannot say things that happen in other conferences. So this talk is going to be like very polite and very nice. And apart from that, I really like the way how things happen in Scotland. So this year I'm kicking off the new company. So it's only myself for now, but I hope it's going to grow. And the focus for this company and like overall what I'm doing, it's about AI and Ruby and things that can go together. And I believe this is a good opportunity for Ruby community and for business, kind of to strike back and to catch a new wave, to do a lot of cool stuff for AI. So if you need any help, ask me. I'm happy to help with AI or Ruby or how to make those things work together. So that's kind of introduction. So my talk is to how to actually leverage AI for multi-agent architecture. But like in asterisk here, so who of you ever done any projects with multi-agent? It's not, multi-agent architecture. Who've heard about that or had any kind of experience? Like a few of you. So the thing for this talk, it's not just about like building multi-agents, but how to utilize what AI brings to us to build multi-agent using AI modules. So it's kind of a little bit narrowed down. But the problem happened nowadays. If you're going to go, like if you're working for a company or product and somebody say, okay, we need to use AI. Or if it's in a startup, say like, let's do AI, 99% you will go with existing platform. So how many of you play with ChatGPT or OpenAI API for the projects? Quite a few, okay. And that's the way how it works. So I think that's exactly the same way how it works for AWS, where they give you free credits, you build your infrastructure around AWS, and when you kind of grow, it turns to be like a huge check. So the strategy here is exactly the same. As soon as you start building something on a platform, it's a very fast track, but the problem comes that it's going to be costly. And a lot of people who use like OpenAI thinks that anything that they see with ChatGPT, that's exactly the same that they can get when they build their own application. So for example, if I want to build my application with chat, interacting with the chat, I envision like it's going to behave as ChatGPT. So do you guys think ChatGPT is a model? Who thinks ChatGPT is a model? Raise your hand. Okay. Okay. They state it, right? So they say the definition is that's the model. And there is definitely models that they create. So they, like, if you answer this question like what took what, it's the true statement. But in fact, the experience that you have interacting with ChatGPT, it's a lot of models in the background. It's a lot of things handling your requests. It's a lot of things giving you different answers. So the one thing that can help you with the code, it's one part. The one thing that can help you with images is second part. Even though they're kind of combining into Omni approach, where one model fits all your needs, but that's not quite correct, specifically when you go with your own things. In most cases, one model is not enough. So if you think about building your own product or integrate any of AI features to your product, if it's a tiny thing in a niche, then it's a good solution, right? So you can use it for categorization. You can use it for interaction with your users. You can use it for whatever you can imagine. But if it is something more complex, one model is not enough. Even you can feed it with your context. You can train it. You can fine-tune it. Usually, and from like my experience, we've started doing AI projects like 6 months, 7 months back. So from my experience, those people who run real AI projects, they have a few models on the back end. Like a regular chat, let's say, that can help people to buy real estate, have 5 different LLMs on the back end. So one to figure out the intent, another one to build the proper communication, second one work with CRM, another one work with the profiles, and so on and so forth. So here we come with the idea of multi-agent architecture, that when you start thinking about building AI project with Ruby, with other technology, we're going to talk about Ruby. So one model is not enough. There is no silver bullet that you can choose and start working with. Or you, of course, can go with the platform. So here's the typical, like the flow for multi-agent ecosystem. So it starts with user inputs. Then the pattern that it implemented here, it's called router skill. So it analyzes what's happening under the hood. And then there is 2 options for you to go. So it's rather calling a function for your model or finding a skill that is implemented in your application. And then on top of it, you can have data and context, any kind of like external, internal API. And when the decision is made, your agent is making next step. And there is 2 options: to complete and give the output, or to request additional data and it circles back to the user. If we look at from the different perspective, exactly the same diagram. If you have n skills, it goes in circles implementing this model router skill, where router initiated anytime when you get a new input, or when any feedback loop hitting this skill from the inside. The good thing that it's pretty trivial to build, so it's not that complex as it might look like. The bad thing, if you want to build it, you need to share the whole context of memory and messages and the application specific. So each and every model that you have need to work within the same context, need to understand this particular flow that you handle in the moment. So the example of this router skill implementation could be, if you imagine like building a Discord chat or any other chat powered by, let's say, OpenAI, which is easy, and you can provide, you're selling something, and there could be like 2 options. So the first one is to buy something. So I want to buy a new Kindle, or to, let's say, to compare, to provide any kind of feedback, to search, to get whatever. And at this very stage, LLM can give you like a very good classification, whether it's a purchase query and you go on the one route, or anything else that you have in the application where the other things can handle that. And based on the skills that's implemented, you can utilize different LLMs on different flows. So let's see quite small but real example of those router and skill blocks. So if you can imagine like the chatbot that help you to buy some stuff, whatever, coffee on a weekly basis. So you can use chat saying like, I'm running out of coffee. And it can make you order, you can pay subscription or buy subscription. The multi-agents here implements different flow. And different routes here can solve different business logic. So it's from product search to tracking to dealing with some kind of promotions and deals for product comparison and suggestions and so on and so forth. And as you can see here, some of the blocks could be like your normal applications that you get used to do and build. Some of them could be external APIs. Some of them could be like even internal APIs if you're building like microservice application. But what new happens here is that some of those blocks really convenient to be substituted with LLMs or with like models that can do better suggestions, better conversation, better instructions. And so if we look at this one and highlight only, let's see those two chains, they utilize 2 steps for the top one and 3 steps for the bottom one for using LLMs. And the problem comes here, then when you think about those interactions between those LLMs, they need to, like when you call an API, right, you have your documentation, you know the verb, parameters, and the URL, and you expect some response back. When you talk into a model, what is the language, or what is the format that you communicate with it? It usually prompts, right? So it's old, but nobody said it's changing. But from the year when ChatGPT started getting to the market, people start saying that prompt engineering in English is the language that machine to machine use to communicate, and that's the easy way to communicate. So if we look here, they communicate in English, right? And because like English gives you so many opportunities to express the same thought, there is no deterministic approach for building those blocks. So for example, if you can imagine this one, those are 3 different models that utilize those 3 different skills that you need to do. And if you think about those 3 models, they evolve. You need to keep them up to date. You need to figure out by yourself how they interact with input and output. You need to figure out how to build your prompts. You need to figure out how to version your prompts. You need to figure out who's dealing with the prompts. So you need to think about, okay, so prompt engineer might be a new profession. So the problem with multi-agent and with the real thing for building those applications is that as soon as you start thinking from the top level to the bottom of building different models, you need to think how to make them work together properly. And in order to update and maintain, if I'm getting new llama that just appeared on the market and I put it somewhere in the middle of the chain, I need to make sure that all my old prompts going to be working properly. And that the whole model and the whole context is going to be taken properly. And furthermore, some of the projects that you work, they say, okay, we cannot expose some of our data to the internet. We cannot send, let's say if it's a healthcare, we just cannot send our data of our patient to ChatGPT because it's not HIPAA compliant. There's a lot of things that we need to keep behind the firewall. So some of the models that you need to implement, you need to own. You need to run it on your own infrastructure. And furthermore, if you're a developer, some of the models you need to run on your local machine in order to debug, in order to work with it somehow. So the complexity grows. So we have different models. It's not clear how to make them work together. And even though they can be on a different level of accessibility, some of them live on a platform, some of them could live on your own infrastructure or even on your own machine. There is no solution, actually. So the theoretical part is done on that, almost. So there is no solution at the moment, but there is one big hope. Who of you heard about Llama CPP? Raise your hand. Okay. And did you guys do anything with Llama CPP already? Okay, some of you. So like, then I will do a little bit, because if everybody's aware, we will skip that. So Llama CPP, that's the product that gives you inference engine for LLMs, for models, so you can run it on your laptop. And the good thing for that you don't need to have GPU. So you can use your normal laptop for the development machine like mine, MacBook Air, with no GPU, so it utilizes your CPU instead of GPU and lets you run your model on your laptop. But the story behind is so cool. So 1 year back, Facebook with their, or Meta, with their Llama, their model, they started giving it to the university and to the scientists, just to let them play with it and contribute back. But as soon as they started doing that, in a month, the model leaked. So it leaked to the internet, people started sharing it with torrents, And Meta was so pissed off. They started figuring out how to claim, how to sue those people who leaked that. It was like, if you can see here on like 2023, 8th of March, it was like a big article that Mark Zuckerberg and old Meta figure out how to kick the community and get their right to the Meta back. But in a month, literally, like the article was on the 8th of March, but it leaked on February. In a month, on the GitHub, appeared Llama CPP repo. As you can see, the initial commit was done on 10th March by George Gerganov, who lives in Bulgaria. And what he did, he kind of took the model from Meta and make it run on a simple laptop. And that was like so cool, because before that you need to have like a lot of money, a lot of GPUs to run it. And it was so cool, so people even call him new Linus Torvalds, because he did something that really turned upside down the way how we work with the inference engines for LLMs. And Meta said, okay, whoa, if you manage to do that cool thing in a month, we are going to claim back or I'll trial things. We're going to keep it open. We will open source Llama if the community like this can build so cool things, so we are in Meta cannot, keep it. You're doing a great job. And so the last Llama that happened this year, Zuckerberg said, like, it's going to be open source forever. We see value from the community. We see how it's going to be working. So that's happened recently. And so for Llama CPP, it's pretty easy to go. So you can build it by your own, or you can install. Now there is a wrapper using Homebrew. So as soon as you install this application or clone it from the repo, you need to find a model. So who recognizes this logo? It's not just emoji. Okay, keep your hand if you have account there. Okay, so this thing called Hugging Face. So Hugging Face, people call it GitHub for AI or GitHub for LLMs. It's repo where people share their models, data sets, feedbacks, and instructions how to use that. So as soon as you have Llama CPP running, you need to find your model. You go on Hugging Face or any other, you find a model that you want to get, and you need to clone it. Usually, models are pretty heavy. So for example, like this one is a small one. This one we're going to use for demo. But usually, if you want a normal model, you need to have like 32, 48, or even more gigs of RAM, gigs of space. And then, if you're going to run it on CPU or on your machine with no GPU, you're going to need the same amount of RAM to run it. But as soon as you download it, the good news is that in Llama CPP, you have a converter, which makes any model that you can get from Hugging Face to this. It's called GGUF format, but it's actually the format that you use for this inference engine, and it works in a second. So this one actually converts the model from 40 gigs to use GGUF format, keeping its size and keeping all the weights in place. So it's going to take like a minute for you to take the GPU-based model and convert it using your laptop for the local format. It's very nice. So as soon as you have this model ready, you can run it on your machine. So you don't need to have anything. So it's a binary file to some extent that you can easily kick off and use it. But it can take some time. As I said, for example, if you have model like 14 gigs, you need to have 14 gigs of RAM. So the second good thing that you have with Llama CPP is that you can cut it in size. So they have built-in quantization mechanism. So what quantization does is the size of the weights that you have in a model, usually 32 bits, and quantization just like blindly cut it. So we're going to use like 4 bits for demo, So it's from 32, it cuts it to 4 bits. The model turns to be like smaller. The model that we're going to use is 4 gigs. It's 4 gigs of RAM, which is good. You want 8 bits, 8 gigs of RAM. And it's pretty fits to your development process. So let's see what we can do with this Llama CPP. So first thing is we can run it with your local machine. And for this purpose, you can have like built-in Llama server command. You can have model that you've just converted, and you specify your port that you would like to run it. So you click run, it kicks off the inference engine, and you're going to have the model up and running. So as soon as it's on your local machine, on the port, you can open it. It gives you web wrapper, and you can ask, what is the best whiskey in the world? And here we go. So it lives in my machine. It weighs 5 gigs. It cuts to 4 bits. And it's still doing a pretty good job, right? So how we can use it for our development side? The first thing is there is native extension that provides C bindings to Llama CPP. If you're going to use it, you can go and install Llama CPP gem, and you're going to have something like that. So it's 10 lines of code. It's instantiate new model. You provide a model path as the local binary that you have. And then, using just plain Ruby, you can ask it questions, and it gives you back within the context, within the memory, within your application that you have. So let's see how it's going to be working. So as you can see, it spins the same. Yes, demos never go. Yeah, they get rid of those parameters. We don't need that. I forgot to remove that. James, I'm sorry. I know I'm running out of time. Okay. Params. So something went wrong. I have 1 minute. Believe me, it works. It works like magic. You don't need to do nothing. It's good. Cool. Okay. So if it's so easy, why don't we use it for our own applications? So we've built at this moment 2 things. So first one, we've built our spec plugin that you can use to use local models as matchers. So you can, in your specs coverage, you can use models to test your code and also use your code to test your models. So using our spec is like 2-way communication. So first, you can keep all your prompts within the R spec and test your prompts running the local models. On the other hand, you can have your models running and testing the thing. I need 30 seconds to show if it's going to be working. So demo 2. And here we have test 3. So, no, just test. So what it has, it's just a normal spec. We have class pirate, and pirates say something like pirates. We have class robot, and robots say something like robots. And then we initialize runner within the R spec. So the first one using OpenAI, another one down below using Llama CPP. And you can say, okay, now spec validate if this class sounds like a pirate or that class sounds like a robot. So let's give it a try and run it. So we're going to run it from the 26 line. So RSpec 26. I hope. Okay, so it starts the model, it gets the context from your Ruby code, and sends it to ChatGPT and validates with the matcher. So you can see, right? So the first one is like a robot, and ChatGPT gives you like this one. So test path, good. This one also sounds like a pirate. And the very last one, I promise. So exactly the same you can do with, let's see, it's probably here, with local llama. So we have local model with parameters. We have here robot speech. And here we ask, OK, test if the robot says something like a robot. Let's run this one for local llama. Woo, for local llama CPP. So it fires up the model, sends prompt, validates the prompt, gets back to the context of Ruby code, and do matchers. So now we have 3 matchers, all, any, and specific matcher, and we have 3 runners. So for OpenAI, for Llama CPP, and for all Llama. While we're waiting, that's it. Thank you very much. I hope it's going to be working, but yeah, I'll be happy to answer all your questions upstairs. So, yay, it worked. Cool.